Well, good morning, everybody, and welcome to day 3 of Dreamforce. I'm not quite sure how many of you are here to listen to the presentation or find somewhere to sit and eat your lunch. But anyway, my name's Doug Merritt. I'm the manager of Platform and Security SEs based in Melbourne, looking after all of APAC. So I appreciate your time today. What I'm going to be discussing is Salesforce's multi-tenant architecture. We're just going to be talking about the core of Salesforce, so the platform, and Sales Cloud and Service Cloud and that sort of stuff. I'm not talking about Marketing Cloud or anybody else, just that one. So, you will have probably seen this slide about 8 million times already. I'll still explain it this time because this is our forward-looking statement slide. Please always base your purchasing decisions upon current technology, not about future stuff. So, without further ado, let's move forward. So Salesforce's trusted infrastructure is actually what you're using today. So thank you very much for becoming a Salesforce customer. So what we have is the underlying structure, which is the Salesforce data centers, et cetera, running the different fit-for-purpose architectures for every one of our different clouds. Because Marketing Cloud is different to Core, which is different to Commerce Cloud, which is different to something else. So therefore, we don't have one architecture, we have multiple, but we make it a unified service delivery across the top, which makes it just seamless to you, our customers, when you start using all of our different clouds. So today I'm just going to be discussing our core Salesforce. So let's get into multi-tenancy. What do we mean? Well, multi-tenancy means one cloud for many, many customers. Salesforce has over 150,000 paying customers today, and what we have are 75 production instances. What's an instance? An instance is basically a lump of technology. Database servers, app servers, web servers, search servers, et cetera. These instances are where you run your version of Salesforce. It's one code base, one database, and your stuff runs inside that environment. So some of you are on NA55, some of you are on AP2, some are on EU7. These are what we call instances. Now, the instance has platform services. The platform services is basically the Salesforce code that we write that supports what you do. So there's one version of code. And how do we separate your data from everybody else's data? Well, we do that by using what we call the org ID, the organization ID. That's a unique 18-character code, and that code is used in the database in both the metadata and data tables. So I talk about metadata and data. Well, what's the difference? Metadata is data about data. Or should I say data? Sorry, I'm in the wrong country. Doesn't matter. So with the metadata, what it does, it describes your version of Salesforce. So when you go to create a new table, you're not actually creating a table at all. You're creating a record in a table called table. When you create a field, you're not actually creating a field in an Oracle database. What you're doing is you're creating a record in a table called field, et cetera. So that's what metadata is. When you change a report, stored in metadata. You write some code, stored in metadata. Do a process builder, it's stored in metadata. It's all metadata. So your version of Salesforce is basically your metadata. Then your data beside it is sitting with everybody else's data as well. And that's how come the horizontal line is there. You see your version of metadata and your version of data, and that makes your version of Salesforce yours. So, what does multi-tenancy mean for Salesforce R&D? Well, it says one version, actually not quite true. There's 2 versions of Salesforce. This one and the next one, that's it. We don't have to worry about supporting any old technology. We don't have to worry about supporting any old versions of Salesforce. Everyone's on the most recent release all the time, and away you go. Now, that gives a couple of great things. We've got our agility. We can do 3 major releases every year, and you benefit from that, all of our innovation that happens. We get roughly 400 to 500 different new features every release. So that's how we manage to do our magic. The instance architecture actually makes that easy to do. So we roll out the new release to every instance on a rolling basis. So over a space of about a week or so, there will actually be a period of time when the sandboxes and the production are out of sync, but that's because we're letting you have a pre-look at the next version of Salesforce. And automation, we run tests. We run hundreds of thousands of tests across Salesforce. So before we do a release, we actually check that our version of Salesforce is not going to break anything you've already got, because that's one of the tenets of Salesforce trust. It's got to be performant, it's got to be secure, and it's got to be up. So having it actually work is quite important. So we do thousands and thousands of tests to make sure it's going to function for you after the release. So what are the key architectural principles we use when we start building Salesforce? Well, we use stateless app servers. What does this mean? Well, every time you make a request, either via the API or via the screen or via your mobile device, what it does is it will talk to an app server process, and then it will promptly forget about you. The next time you make another request, it has to go maybe to a different app server. Now, if that's the case, how does it keep context of where you were? Well, your context is stored within the database. That means any app server on your instance can actually process your request. So the app server thread that runs your bit of code could actually be run by Michael Dell 2 milliseconds before you. He was doing his stuff in Dell, and then you run your query, and it ends up running the same app server. But stateless makes it all work. The database, the system of record, we don't do any data definition language. So we don't say create table or create field. None of that happens at runtime at all. That's only done during the upgrade cycles. We've got smart primary keys. So those of you who've looked at the URL at the top of the Salesforce thing, every time you go to an account, the URL ends in 001. 001 and 15 characters is an account ID. 005 is user. 010, I think, is opportunity, but I could be wrong. Anyway, so the first 3 characters of the record ID actually determine what object it comes from. So that's a pretty clever way of doing some nice stuff. We do some magic under the covers as well. We use Oracle under the covers to actually run Salesforce as a relational database. We also use Hadoop as well. But under the covers with Oracle, what we do is we use every trick in the book to make Oracle work quickly, because Oracle's not designed to work in a multi-tenant manner. So what we have to do is we build our entire stuff on top of that. So we do a lot of magic, amazing denormalization, et cetera, to make it all function. And we'll talk about that in the next couple of slides. So what's a data structure actually look like? So in the middle, we have your data, well, and everyone else's data as well. So your data and their data live in a data object. I'll describe what that looks like in a sec. We have character large objects. So these things are called CLOBs, and that's where you store your attachments, et cetera. Now, on the left-hand side, we have metadata tables. Left-hand side, we have metadata tables. These metadata tables, as I mentioned before, are things like the object table, the field table, the page layout table, the report table, etc. All this metadata is stored in these tables. And then on the right-hand side, we have the specialized pivot tables. So to actually make sense of this data, we've got to have indexes, unique fields, relationships, etc. A whole bunch of these other tables that we use, you never see, to actually make sense of how we store the data in the data table, for example. And here's a pictorial example of this. So on the left-hand side, we have the data object. In the middle, we have the object. On the right-hand side, we have fields. So what happens is, in the object table, we've got an object ID, the org ID, the object name, is able to be used in reports. All that sort of attributes you see when you create an object, that's stored in the object table. On the field table, we have a field ID, the org ID, object ID, field name, data type is indexed, what the field number is. Now the field number is important, because if you go to the left, you see you've got value 1, value 2, value 3, etc., to value 500. The field number is what value it is. So this definition is completely soft. Whenever you create a new field, you're not creating a field at all. You're creating a record in the field table, which then will point to an empty value column in the data table. And away you go. So, fields point to your data. That's how it works. So, this is what it looks like in the real world. We have a global unique identifier for every row. The org ID is stored there. That's how we keep your data separate from everyone else's data. So whenever you write a query in SOQL, you say, give me every opportunity where the opportunity close date is whatever, right? You build a query. We always add and org ID equals to every query to make sure that you only see your data. Because if we leak data, we're dead, right? That's the whole point of Salesforce, to keep your data safe. So the whole point of this is to make sure that you don't see anybody else's data and they don't see yours. So, global unique identifier, org ID, object ID, value 1, 2, 3, 4, 5, up to 500. And as you can see, each value could hold numbers, could hold dates, could hold anything, could hold encrypted values, for example. So how do we store that? We're all stored as characters. Everything's stored as a character, no matter what. So date's stored as a character, a number's stored as a character, currency's stored as a character. Everything's stored as characters, which means that we have to convert that. Well, I like the technical term, we transmogrify it. That's worth about 87 points in Scrabble if you want to use that. Anyway, so we actually change it from a character into whatever type it has to be, and then we send it out via the API, or we stick it on the screen appropriate for your use. Now, how do we do an index? Because if everything's a character, you can't sort it, right? Because character 1 actually sorts in a weird order. If you have 0, 1, 2, 3, 4, 5, 6, 9, 10 comes before 9 if you do it in characters, right? It doesn't really help. So what we do is we actually have another table called index, and we copy the data out of the data table into the index table into the right type. So you see string value, num value, date value. So we copy the integer, for example, that you stored, we copy that into a string into the data table, and then we copy it as a number into the number column in the index. And then we index that thing over here. So when we do a query, we actually don't do a query on the data, we do a query on the index, get the org ID, object ID, and the GUID, and then pull the GUID out, and go back over here to the data column, and pull your data out and do that. So it's quite an interesting way how we approach it. But we have to do it that way, because how can you do indexes on characters? It doesn't work if it's a number. So that's what we do to make it go quickly. And we also do unique fields, et cetera, et cetera. That's exactly the same as a normal index, but it's marked as unique, not non-unique. There's also relationships and everything else as well. So this is fully described in a white paper we have called the Multitenancy white paper. If you go to developer.salesforce.com and look up multi-tenant white paper, you go to a nice little blog which explains how this all works. We've got a patent on it, so we're happy to tell you all about it, because if you copy it, we'll sue you. That's fine. So the beauty of the whole technique is that we make this an extremely flexible, extremely capable platform that you don't have to worry about. It just works. Now, any of you out here who actually are computer science people, you will realize that doing a completely soft database structure is what we call in the technical industry non-trivial, i.e. it's really hard. And the trick is, we actually do this for you. So every request you make is dynamically created for the response. So whenever you make a page request or you do an API call, the response is generated on the fly every single time. So if your system admin changes the field layout and hits save and you hit go, the page will just refresh automatically. Nothing's pre-compiled. It's done totally on the fly. And we do every request on average around 200 milliseconds. 200 milliseconds to do all of this magic. So we've got some pretty cool developers and pretty quick hardware. So how do we make it work? Well, we partition for performance. So all the data and metadata is split up. Your org ID is a 16-digit number. We'll actually put that through a hash function. A hash function is just a mathematical function that takes a big thing and makes it into one of these numbers from 0 to 31 in our case. And because your org ID will come to one of those 32 numbers, it allocates you to 1/32 of the database. So we have to search this much of it, not the whole thing. We just know it's going to be over here. So that makes it a lot quicker for us. Now, I talked about doing queries. So when you write a SOQL query, if you said, give me all the opportunities where the opportunity ID equals 7, right? That's going to be remarkably quick, because it's going to use an index, it's a where, it's an equal sign, really quick, no problem. But what happens if you say, show me all the opportunities? That's going to do a table scan in the old days for those guys who write SQL code, right? The trick is, though, with Salesforce, it depends upon where you are on the role hierarchy as to how much data you can see. I'm the lowest of the low in Salesforce. I'm at the bottom of the hierarchy. I only see my stuff, nobody else's. Whereas Mr. Benioff up here can see everyone's data. So if I run show me all opportunities, what'll happen is it'll check my visibility. It'll say, Doug can only see this much. What I'll do is I'll actually pull that data out and to show him that. Whereas Mr. Benioff runs it, actually it will use the index because it actually wants all the data. And the filter selectivity. So filter selectivity just means, is it an equal sign or is it not? If it's an equal sign, it'll always use the index because it's going to be fast. But if it's not, then it will do something else. So what we do is we do a whole bunch of queries of the metadata to understand what you're actually asking for. Then we'll build a particular SQL query with the and org ID equals whatever at the end of it, and then run that against the Oracle database to pull back the data to then make it into your output. Like I said, it's pretty complex stuff, and we do it in under 1/5 of a second every request you make. Multitenant search, interesting as well. When you do a search in Salesforce, so the global search at the top, or if you use a SOSL query, that uses the search capabilities, not Oracle. We actually store a search index outside. We use something called Solr, S-O-L-R, open source technology. And what we do with that is we copy all the text out of your records and stick it in a Solr index. We also take the contents of PDFs, Word files, Excel spreadsheets, that sort of stuff, and copy them out into there as well. So that way when you do a query at the top of your Salesforce, it'll actually find everything. Chatter, records, files, you name it. It'll find it. It'll also search outside of Salesforce now because you've got Files Connect. So we can connect to Google and you can actually search all your Google files. So all that sort of stuff comes free of charge with the platform. So that sort of capability is really quite powerful. Now there's something here called FFX. That means FileForce Extreme. You've got to be extreme. You can't just have FileForce, right? It's FileForce Extreme. And basically that's how we store this large objects. So not only do we use it for our multi-tenant search, we also use it for storing all of your attachments, because storing them in an Oracle database doesn't make much sense. We store them out on a file system and then manage it that way. We replicate across to a backup instance, so you have your primary and your backup, so all that data is replicated across exactly the same way as your real data is replicated across. And now we're going to discuss actually how we do our multi-tenant architecture. What do the machines actually look like? Well, what we have is a data center, and your data lives in 2 data centers, and that's it. It lives in your primary data center, and it lives in your failover data center. And what happens is this data lives in one of these instances. So each of these little cubes is an instance, and we have instance groups. So you see on the left-hand side, there's the core instances. So we might have NA45, NA50, NA73, whatever, right? There's a group of 4 core. Then we've got core DR. So in the same data center, we're running primary and we're running somebody else's secondaries. We've also got primary sandboxes and failover sandboxes in the same data center. So basically what we're doing with these instance groups is keeping them separate. Now, why do we do these instance groups? Well, it makes it easy to cope with failures, because what we do is we put a whole bunch of shared services for that instance group. So if something goes wrong, it's only going to affect those instances and not all instances in that data center. So there's things like search engines, there's the file FFX sort of stuff all happening in there. That's where Einstein lives as well, etc., etc. But then we have actually data center-wide shared services, things like our HSMs for platform encryption and that sort of stuff. So that has to live at the data center layer because that's quite expensive technology, so we share it everywhere. But everything we have is at least N+1 to make sure that if something does go wrong, we still can keep running with that technology. So how do we actually replicate data? Well, your data is kept in 4 places. We have Oracle RAC servers, which are 11+1, so we've got 12 node servers. We have Active Data Guard copying from the primary database cluster to a smaller standby database cluster. Just in case a primary one goes failed, we can flip across quickly to the standby one. The performance will go down, but at least you still work. But also live, we're replicating across the wide area network to your failover data center. So the failover data center has all the same transactions, slight delay, into that database. It then does the replication locally as well. So if something goes wrong in the primary, we can flip across to the secondary. At the moment, we're looking to have that switch in around about 10, 15 minutes, which is pretty impressive, because also we have to do a whole bunch of stuff with the internet to tell them that NA45 is not over here anymore, it's actually over there. So we do all that sort of stuff. And nowadays, we're not doing failover and fail back. We're doing what we call site switching. So from now on, every 6 months or so, we're just going to flip to the other data center. And that way, we know that it's always going to be up and running and capable of actually failover. Because people say, that's great, you do your backups, but do you test them? Well, we obviously test them, but we also will fail over now to show you that, yes, actually you're running on the other instance all the time, so to keep flipping backwards and forwards every 6 months or so. Now, what actually is an instance? An instance is your shared database, so your data tables, your metadata tables, your pivot tables, also your metadata cache. Now, because every page, every API response is generated for you on the fly, the metadata is key to making that happen. So that's got to be in memory, because otherwise it's going to be quite slow. So we cache basically entire metadata tables into memory. Now the trick is, your admin comes along, updates your metadata, hit save, we've got to then make sure the cache reflects that. And that's a whole talk in its own right. I'm not going to go into that at all, but that's quite scary. We do a lot of bulk data processing. We've got our multi-tenant query optimizer in there. We generate the app at runtime, et cetera, et cetera. So all this sort of stuff is what makes up an instance. So without that, thank you very much. Appreciate your time. I'm out of time now. I've got 8 seconds to go. So what I'd like to do, if you don't mind, is I'll take some questions. I'll be standing over here at the end. So I appreciate your time. Thank you very much, and enjoy the rest of Dreamforce.